Hi, everyone. Sorry I had to miss class today, but I didn't want you to miss out on your review. And I thought it would probably be best to review with me than another instructor since I wrote the test and I'll be grading your test. I am feeling better, so thanks to those of you who have asked. I ended up in the hospital with baby's positioned very poorly against one of my kidneys, which caused a kidney infection, which caused a plethora of other fun things, not to mention my iron tanked. And so basically, I'm just fighting a bunch of fun pregnancy things, and I'm never doing this again. Anyway, so today I just want to walk through the practice test that I sent out in email. At the end of this, I will also post this answer key for you to practice. Please note that this practice test is made by me. It's not the same as the one you find under tests in Blackboard. I made this one as I made your real test. So that should tell you maybe some important nuggets of information that you might need to know. It's very similar. Additionally, for your attendance credit today, you will do a quiz in Blackboard. And I would highly encourage you to know how to get those too, as they are even more similar to your test. A few of them may be seen again if you get my drift there. So let's go ahead and dive in. I don't want to waste any more of your time than necessary. The first question that we see has a recipe requiring 5 cups of sugar for 12 servings. And we want to know how many cups of flour, that should be sugar, see, I'm losing my mind, will be required for 32 servings. I'll go ahead and fix that. So we have to use a proportion here to solve. You can guess that your test must say flour or sugar, and I didn't change one of them, huh? Okay, so remember that a proportion, in the first one, we know that 5 cups of sugar are required for 12 servings. And we want to know how many cups of sugar, so that's our X, are required for 32 servings. Okay, remember that to solve these proportions, we're going to have that cross multiplication situation. So we know that 5 times 32 is going to be equal to 12 times X. So that means that X equals 5 times 32 over 12, which is going to be, get my calculator out, about 13.3. So we're going to need about 13.3 cups to make 32 servings. That's our final answer. Now, the next one is similar also. Our new car can travel 2,400 miles on 80 gallons of fuel, and we want to know how many gallons of fuel will be required for an 800-mile trip. Now, again, we're working with proportions. You can set this up. Remember, the fraction can go either way. So you can have 2,400 as your numerator or your denominator, whichever way, as long as you're consistent with your units straight across. So I'm going to set it up as 2,400 miles for 80 gallons. And this is going to equal 800 miles is going to need how many gallons? And just like before, this is going to give us 2,400 times X is going to equal 800 times 80. So X is going to be 800 times 80 over 2,400, which is going to give us about 26.7. And we can always look at this and think and see if it makes sense, okay? we would expect 800 miles is about 3 times, so we'd expect about 3, it's a third of 2,400, so we'd expect about a third of 80 gallons, which is exactly what we get. So that is our solution here. Remember, with proportions, you want to set them up. You want to check that we have miles and miles and gallons and gallons. You want straight across your units to be the same, and then use cross multiplication to solve for X. You'll do that in every one just like this. Now we're going to move into a slightly different concept. When you purchased your car in 2018, it was worth $26,800. And this year it's worth $18,400. By what percent did its value decrease? Remember here that we want to look at the change and we want to divide it by our reference. Generally here, our reference is our purchase price. Okay, so what it started with, this is going to be our reference. Okay, so it went down, it changed by 26,800 minus 18,400 over our reference, which is 26,800. And we can enter this in our calculator carefully all at once. And that is going to give us 0.313 roughly, okay? Excuse me. Remember to use percent though. This is your decimal form. So as a percent, we want to say that it changed by 31.3%. Okay, and you can look at that and see if it makes sense. And we see, yeah, that makes a good bit of sense, right? It's practical. Numbers that you want to be careful with if you get something over 100, something that's crazy high or crazy low, you want to make sure that you look more into. Okay. Now we have a flight from GSP to Key West. That would be nice. Is regularly priced at $550. The airline has a special right now and they've discounted the flight by 22% this week. How much are you going to pay if you buy it while it's on sale? The easiest way to do this is to do that shortcut, okay? So we can do the original times 1 minus the discount as a decimal, okay? So our original is going to be 550, and we're going to multiply that by 1 minus 0.22. And if we enter that into our calculator, we are going to get $429. No need to round here. Typically, if we're dealing with dollars and we don't get an exact answer, you'll round to 2 decimal places. If I don't tell you to where to round to, you can use common sense here. I'm not going to be too picky. Just show your work and make sure that it's not, you're not rounding to hundreds or something. So, does that make sense? Yeah, it does. Remember, you can always go back and check your answers also. Now, the next one is very similar, but we have to do consecutive discounts and consecutive upcharges, okay? So a furniture set that's regularly priced at $900 is discounted 15%. So our first one is a 1 minus 0.15. But we have a coupon for an additional 7% off. So that's going to be 1 minus 0.07. But then we also have to pay sales tax, and that's an increase, okay? So the easiest way to solve this is to start at 900. You're going to have your initial discount. Then you're going to have your coupon discount. Then you're going to have your sales tax, which is a plus. Okay? So this is the discount. This is a coupon. Both of those are minuses because they're decreases. And this is your sales tax. Okay? You can enter this all into your calculator using parentheses carefully. And you're going to get $768 and around 37 cents. So again, you want to check and make sure it makes sense, that it's practical, and it is in this case. Okay, now we're shifting gears a little bit to another section, and we're talking about markup. Garfola Goods purchases an item from the manufacturer for $200 and then sells it for $320. We want to calculate the percent markup. Remember that the percent markup can be based on two different things, and it's going to change our answer. So when we say based on cost, our reference is cost. Okay, and the next part we're basing on selling price. So our reference is going to be our selling price in that one. Either way, our numerator is the same. What was the difference in what we sold it for and what we bought it for? So our percent markup is going to be that difference. So 320 minus 200 over here. It's based on cost. So our cost was 200. And if we enter that into our calculator, we're going to get 320 minus 200. 0.6, which is 60%. Okay. We do the exact same thing for the next one. We still have the difference on top, so 320 minus that 200. But now we're basing it on selling price. So our reference here is now 320 instead of that 200. That is going to be 0.375 or 37.5%. Remember that the percent based on selling price, as long as you're not selling it at a loss, is going to be smaller than your percent markup based on cost, because you're going to have a larger numerator, or a larger denominator, excuse me. Okay, good so far. Remember, you can pause this video as you need to work them, to digest them, rewind them, to review them, whatever you need to do. I promise you that your test is extremely similar to this. Okay. Number 7. After a 15% markdown, an item sells for $4,600. What was the original price of the item? Well, to do this one, remember that our selling price is going to be the original minus the discount, okay? So we know that $4,600 equals our original price, let X be original. So it was the original minus the discount. So minus 0.15 times the original. Because remember, we're going to take off that 15% discount, okay? Remember from class, there are a few ways to solve this. There are different ways. They're all mathematically identical. So whatever makes the most sense to you, this is what makes the most sense to me to jump straight to. If we combine like terms, we see that 4,600 equals 0.85x. And then we see that 4,600 divided by 0.85 is going to be x, which is going to give us $54.11.76. So the original price here was $54.11.76. Now remember, you can always check this. If you do $54.11.76 times 1 minus 0.15, because we're taking a 15% discount, sure enough, minus rounding error, you get really close to $4,600. So you can always check your answer there, going backwards with the other versions that we know. Okay, let's move into interest here. You take out a $15,000 loan with a 3% add-on interest rate for 48 months. It's important to note that 48 months is 4 years. How much total interest will you pay? Remember, the add-on interest is simple interest. So you're just going to have I equals PRT. Your P here is your 15,000. Your rate is 0.03. And your T is 4 years. And so if we multiply all of that together, we get 1,800. So you're going to pay $1,800 in interest. Now your monthly payment is going to be the total you pay divided by your number of months. Well, the total that you pay is going to be your original, so 15,000 plus your interest, the 15,000 plus 1,800 over those 48 months, which is going to give us $350. Now you can always check this too. What's 350 times 48? Well, it's $16,800, which, if we go back, is the same thing as our numerator here, right? $15,000 of principal plus $1,800 of interest gives us $16,800, and that's exactly what we expect. Now we can talk about average daily balance. In a billing cycle, your balance is, you have a 30-day billing cycle. Your balance is for 12 days, $200, 6 days, $280, 10 days, $150, and $200 for 2 days. You know we're taking basically a weighted average here. As one of your classmates mentioned in class, I believe it was Cassidy, you can do this with a frequency table if you wanted to use your calculator like we did in the last unit. The textbook way to do this is to take a weighted average and simply multiply. You have $200 for 12 days plus $280 for 6 days plus $150 for 10 days plus $200 for 2 days. And you're going to divide that by your whole 30 days. Okay, if we do that into our calculator very carefully, we will get $199.33. If we look at those numbers, that makes sense. That's a practical answer. Remember, if you'd gotten a number, if you'd gotten 500 here or something, that would not make sense because it should be somewhere in the middle of all these numbers. Now, if our annual interest rate is 12%, what is our finance charge? Well, remember to find this, you're going to just go back to I equals PRT. Remember, your finance charge is nothing more than your interest. Okay? So, here, when you do this, the P is going to be your average daily balance. So we're going to have $199.33. our rate is going to be 0.12. And our time, remember this is where it's tricky, is going to be, remember that time is in years. So it's 30 days out of 365. His annual is 365 days. Okay. If we multiply all of this out, we are going to get $1.97 roughly. So for that month, we're not paying a ton in interest. We're paying $1.97. Okay, moving right along. This one's the long one for us, right? We buy a car for $25,000 and we make a down payment of $3,000 and we have to finance the rest. Your payments are $450 per month for 60 months, which is 5 years, remember? And we want to answer the following questions. The first one is the easy give me, right? Don't overthink the first one. How much money do you have to borrow? Well, remember that you're going to have to borrow whatever the cost is, minus your down payment. So that is going to be the $25,000 that the car costs minus the $3,000 that you put down. So that is going to be $22,000, right? 25,000 minus 3,000 is 22,000. Don't overthink that part. On the test, each of these parts is worth equal amount, so that's nice. How much are we going to pay back to the lender? Well, how many payments did we make? And how much were those payments? So we made 60 payments of $450. Okay. So $450 times 60 payments is going to give us $27,000. Okay. So we paid $450 per month for 5 years or 60 months. So we paid $27,000 back to them. Now remember, that's how much we're paying on that $22,000 that we borrowed. That feeds us into the next part. How much interest did we pay? Well, your interest is going to be your total paid minus what you borrowed. Or sometimes we'll see this as A minus P, the amount you paid minus the principal that you borrowed. And so that is going to be the $27,000 that you paid back minus, what did we borrow? The $22,000 that we borrowed. And that is going to be $5,000. So we pay $5,000 in interest on this particular loan. Now our annual interest rate is only asking us for the I, not the I. Let me erase that. It's asking us for the R in the I equals PRT. We know everything in this equation except for R. We know from above that we paid $5,000 in interest. Okay. We also know that we borrowed $22,000. We don't know our rate, but we also know that we borrowed it for 5 years. Okay? So R here is going to be found by finding 5,000 divided by that 22,000 times 5. If it helps you, you can certainly multiply those out first. Make sure that you're careful with your order of operations here. Use your parentheses in your calculator. The whole denominator needs to go into parentheses here. And you're going to get 0.0454, or we can say about 4.5%. In fact, let's let it be for rounding's sake. Let's be careful for our next ones, I guess. And let's let it be 4.55%. Just so we get a more precise answer later. If you had done this on the test and you left it at 4.5%, I'd be fine with that. Your answer won't be far off. Remember, your APR is different than the simple interest rate. And it's kind of your effective interest rate. And it's always going to be higher than that annual interest rate. And this is why why our lenders have to report this. Remember, based on the formula, we have an estimate for APR, which is all you guys are expected to do. So it's roughly equal to 2 times N times R over N plus 1. Now remember, N is your number of payments and R is your rate. So this is going to be 2 times the 60 payments that you made times your 0.0455 from before that we found, divided by that 60 plus 1. So you're going to want to do this very carefully in your calculator, as always. You can't read my handwriting. Let me fix that. So 2 times 60 times 0.0455. And it is going to tell us that our effective interest rate is somewhere around 0.0895. So that's going to be around 8.95% or so, which, as we can see, is a lot higher than that annual rate. So the truth in lending would make it so that we knew that, hey, you're really actually paying a lot more. Because remember, when it's compounding like that, you're making payments. You're not holding on to that money until the very end. You're making those payments. So effectively, you're paying more interest as the time goes. So what is the total amount that you paid for the car? Notice that this is slightly different than part B, okay? The total amount that you paid for the car is what you pay back to the lender, but you also have to go back and add your down payment, okay? And so remember, from way above, that we paid back to the lender $27,000 in part B. But also remember that we also put a down payment. We made a down payment of $3,000. So everything you're paying for the car comes together to be $30,000. So that car, even though it was a $25,000 car, you are going to end up paying $30,000 for it, and that's in your interest. Okay. Number 11 is everybody's least favorite. It's not hard. Remember, you have a formula sheet, and you just have to be very, very careful with your order of operations. Work it in pieces if you need to, however you need to do it, and remember to use your formula sheet. You're going to borrow $22,000 at an APR of 15% for 4 years. You're making monthly payments, and you want to know how much each payment is. So, based on our formula sheet, our payment is going to be P times that APR over N divided by, and the ugly part is in the bottom, 1 minus 1 plus that APR over N to the negative NT, close those parentheses. It's an ugly, ugly formula here, okay? Now remember that N, according to our formula sheet, as always, our N is how many times we're paying per year. So remember, the P is the total amount you borrowed, the APR is given, N is the payments per year, and T is how many years you have. So here, we have borrowed $22,000. So this is P. Times our APR is 0.15. Monthly payments tell us that N is 12. And then we're going to be very careful on our bottom here. 1 minus 1 plus that same 0.15 over 12. So the negative 12 times we are paying it for 4 years. So T is going to be 4. When we carefully put this into our calculator, we are going to get a payment of $612.28 roughly. So again, pause this if you need to. Make sure that you work through it and you understand how you got this, because that's going to be very important. You will see one of these, and it is a 6-point question on your test. So please make sure that you at least start the formula. Show me your work, because it's easy to make a math error here. And if you set this much up and it's all right, and you just make an order of operations error, it's going to be a minimal points deduction versus just taking a wild guess and losing all your points when the answer's wrong. Okay, number 12. You invest $10,000 in a savings account that earns 3.2% interest and it's compounding quarterly. How much money are you going to have in 8 years? Remember, our formula here is A equals P times 1 plus R over N to the NT. Okay, N again is how many times per year we're doing it. Okay, so quarterly is N equals 4. T here is 8 because we have 8 years. Okay, and our P is 10,000. We know that our R is here, and we're good to go. So we're going to have $10,000 times 1 plus 0.032 over 4. So the 4 times 8. I'm going to enter this into our calculator. Excuse me, guys. And that's going to be somewhere around $12,000, $904.38, roughly. On number 13, we want to have $25,000 in a savings account in 18 years. How much should we invest today if we can earn 2.8% compounded monthly? So now we know that N is 12. We know that our T is going to be 18. This is the amount that we want. This is A, and we're looking for P, okay? This is going to be our R. We're going to use the same formula as before. So we're going to use A equals P times 1 plus R over N to the NT. But now we need to solve for P. So we know that we want to have $25,000. We don't know P. 1 plus 0.028 divided by that 12. To the 12 times 18. Okay. So we're going to solve this one for P. We're going to take 25,000 over all of this. And that is going to give us $15,111.60. So not a bad return. We need to invest around $15,000 today to have around $25,000 in 18 years. Okay. An item is sold for $800. If markup is 10% based on cost, what was the cost? Just as a note, this is a bonus on the test, and this is a bonus on the test. You get a reward for actually watching the video. So if an item is sold for $800 and markup is 10% based on cost, what was the cost? Well, we know that we sold it for $800. And we know that the original, that would be a 10% increase from the cost. So X plus 0.1 X. So 800 is going to be 1.1 X. So 800 over 1.1 is going to give us $727.27. That was the original cost. Now you can go back and check that with our original markups from earlier in the test, right? You can say, okay, well, 800 minus 727 divide by our cost of 727, and it's roughly 10%. So you can always go back and check it. It was based on cost. Or that's your percent markup. The last one that we have here is that the cost of a certain item has quadrupled due to inflation. By what percent has the price of the item increased? Well, here, remember to use real numbers. It's very tempting to say, well, it's quadrupled, so it's 400%. Yes, it's 400% of the original, but what was the increase? Here, I like to start with 1. So it quadrupled. It started at 1. If it quadrupled, it ended at 4. So remember that our percent increase is, well, let's not say start minus because I don't want to get signs involved here. Our percent is the difference divided by the original. Which is going to give us 3. So here we see a 300% increase. Okay, be careful. If it's quadrupled, it's gone up by 300%. If it's doubled, it's gone up by 100%. Remember, you had that original of 100% there. If it triples, it goes up by 200%. Again, you can use real numbers to check it and just use the formulas that we know. Please, please, please take a few minutes and go over this as you need. It is so similar to your test that if you guys can rock this, you can rock your test. If you have any questions for me, send me an email. I'm happy to answer. Otherwise, I will see you on Monday and we will take our test.